We're going to look at a series of application problems dealing with exponential logarithmic skills. I will start off by mentioning that on the exam, I'm going to give you these formulas. So your task is to identify which formula you want and then be able to use your calculator appropriately to manage that particular formula. All right, so the first formula we're going to look at is called simple interest. In this case, I would represent the amount of interest earned. P stands for the principal, and a principal is just the amount of money that we initially start with. So the amount of the loan or the amount that we start off in the bank account. All right, R stands for a rate, and this has to be in decimal form. And T, of course, stands for time, and this is measured in terms of a year. So whatever time they give us, we just need to make sure we convert that number into some sort of yearly amount. Okay, so our first practice question, find the amount of simple interest earned on a savings account balance that has an initial balance of $1,000 and earns a yearly interest rate of 5%. Okay, so our formula, I need the principal, which in this case is 1,000. And then I need the interest rate, which is 5%, so in decimal form it's 0.05. And then, let's see, and then we're just talking about a year in this case. So I'm going to take out a calculator and then we'll type that in and see how much we get. Okay, so I pulled out TI-84 here. And I'm going to, let's see, 1,000 times 0.05 times 1. And so we make $50. Okay, so in the year, we simply made, just for letting the money sit there, we've made $50. All right, compound interest is the amount A after T number of years due to principal P being invested at an annualized interest rate R compounded N number of times per year. Okay, so let me try to translate that in English. When you compound interest, what happens is the bank says, we'll give you 10% a year. Well, they're not just going to look at your account once a year. They're going to look at so many times in that year. So if they compound semi-annually, that's twice. If they compound quarterly, that's 4 times. If they compound monthly, that's 12. Daily is 365. So let's talk about monthly for a second. So when we say monthly, that means that they're looking at your account balance and they're going to give you 1/12 of that interest rate. But then the next month, not only are you earning interest off the money that you put in, but you're also earning interest off the little tiny bit of interest that you got from the previous month. So we like compound interest because that just means we're getting more money off of the money that we initially put in there. All right, so let's kind of set the formula up then, and then we'll look at the calculator skills. So what would the ending balance be? So that's A with an initial loan of $500. That is compounded monthly. So 1 plus 6% in decimal form is 0.06. Or compounded monthly, so N in this case is 12. And then N times 3. Okay, so that's what I'm going to type in my calculator. All right, so let me clear out the last problem here. All right, so we got 500 times parentheses 1 plus 0.06 divided by 12. Then we're going to close that, but we're going to raise that to the 12 times 3 power. Okay, and then I'll hit enter. And I get $598.34. So I almost made $100 just by having them look at the account over and over again. After compound interest, we have continuous compounding. So continuous compounding is the amount A after T years due to the principal P invested in an annualized interest rate. So notice in this case we got rid of N. So you can kind of think about it if we compound monthly versus daily versus hourly versus secondly. Obviously the more times they look at it, the better it is for us. So when they compound continuously, they're just looking at the account all the time, and they're giving us a very small fraction of the overall yearly interest rate on that. Now the nice part is it's a nice formula, as we just end up using E. So in this case it would be our principal is $400 times E raised to the 0.07 times 5. Okay, so then all I have to do when I go to my calculator is 400 times, and then E, and it's going to be different on every calculator, but usually it's connected to the ln button. So in mine I have to hit second ln, and then it brings it up as an exponent, so parentheses 0.07 times 5, and then close that. And I have $567.63. So 567.63. Okay, so the present value formula then is kind of related to the other formulas we've seen. So the present value P of A dollars to be received after T number of years, a certain amount per annum interest rate of R, compounded, in this case, N times a year versus compound continuously. So we've got two different formulas. Notice in both cases they both have a negative exponent, so that part's very consistent about this. But what the present value is let's say in 5 years I'd like to buy a car, and I know the car that I want, and I know I need to have $20,000 set aside for it. So knowing that in 5 years I want this amount, the question then is, well, what do I have to put in the bank now so that it just sits there and accrues interest for 5 years? How much would I have to set aside today so that I have that amount? Another example that might sort of hit home a little bit, hopefully not too harshly, is a college fund for children. So, when kids graduate high school and mom and dad want to help out paying for college, the present value formula would tell mom and dad how much money do we need to set aside today so that they have a certain amount 18 years down the road that maybe they can use that for college. So anyways, that's kind of what this particular formula does for us. So question, how much would you need to set aside if you wanted to have enough money saved up in the bank for a car in 5 years? You estimate you'll need $15,000 and then the following interest rates. Okay. So we want P equals, in this case we got 15,000 times 1 plus 0.06. Now they're compounded monthly, so monthly means N is 12. Raised to the negative, sorry, N is this, in this case is 12 again, times 5. So that's what the present value would look like compounded monthly. Compounded continuously, it's a little easier. So here we still have that 15,000. This time it's just E to the negative 12 times, I'm sorry, we don't need 12. We don't need N, we need the interest rate. So 0.05 times T, the number of years. Okay, so now that's what we're going to type in the calculator. So let's start with the compound monthly rate. So clear that out. So 15,000 times parentheses 1 plus 0.06 divided by 12. Then we're going to raise that to the, then I'm going to do another set of parentheses, negative 12 times 5. Okay, and I get that if they just want to have 15,000 in 5 years, they need to have 11,120.58. So 11,120.58. So they'd have to go put that money in the bank and let it just sit there for 5 years. On the E side, so 15,000. This time I just want e to the x, so e to the negative 0.05 times 5. Oops. Yeah, in mine I guess I can get away with not having parentheses in the exponent, but yeah, you might need it in yours. Okay, 11,682.01. Okay, and so that's how much money we would have to set aside if they were going to compound continuously versus that one. Oh, I just caught a mistake. My interest rate. Oh no, it's not a mistake. Never mind. I did exactly what my paper said. Sorry. One of them I had 6% and one had 5%. So that's why the numbers are a little differently because the interest rates change for each one. But that is correct. You know, I did set the formula up right and then type it in correctly.